Welcome to PyData Global 2020, and I definitely want to thank you for being a speaker. Since this is your time, I'll just go ahead and hand off right to you.
Thank you, Stephen. Hello, everyone. I am Mitali. I am Senior Data Scientist at Saturn Cloud. And today I would be talking to you about getting started with Dask using Saturn Cloud. Okay, so before deep diving into any of the data sciencey stuff, I want to talk to you about Formula One. So whenever there is a Formula One tournament, there is a pit stop. This pit stop lasts for generally 2 to 4 seconds. In fact, the shortest pit stop has been of 1.84 seconds. And in this small time, many tasks are done. Refueling is done, some mechanical adjustments are made, and the tires are changed. How is it possible to do so many tasks in such a small time? It is possible because we have n number of people working together. They're working all in parallel. There is this one big task, which is pit stop, but then they are dividing this task into small parts. And this is exactly what parallel computing is. That is dividing the problem into small parts and solving it at the same time. Okay, so why do we need parallel computing in data science? Python is a friendly language and it is quite popular among data scientists, but on its own, it is not fast enough. So there is this lock, which is known as global interpreter lock. I won't be going into the detail of what this lock is, but what happens because of this lock is that Python cannot utilize multi-threading for CPU intensive calculations. So we would need some toolkit so that we can enable the distribution of work amongst multiple cores if you are using a single machine, or amongst multiple machines if you are using something like Dask distributed. Okay, so what all can we do with parallel computing in data science, and where all can it be used? Imagine you have a bunch of files, or you have some data which has billions of lines, and you are trying to load this data on your machine. You might run out of memory because your data is so large that the memory of your machine is not big enough for that. It has happened with me so many times that I want to do some hyperparameter tuning or trying to just run some train my model. I started, I go out, I come back, and my model is still running. It sometimes takes so many hours. So for all these scenarios, if we have parallel computing, then we will have more memory and we can run all these computations much faster. Okay. So of all the toolkits on the right, you see there is Dask, there is Spark, there is Ray, and there are some more. So of all these toolkits, we are going to talk about Dask today. So what is Dask? So Dask is a free and open source. Big advantage if you are a Python user, because the debugging becomes really easy. So Spark is also a popular toolkit for parallel computing. But so it has, if you compare it with Dask, there are pros and cons. So Dask is lightweighted. That means that it cannot support all the languages, unlike Spark. But if you are a Python user, then Dask is a great tool to use because it can integrate very nicely with the existing Python ecosystem. Okay, third point. Dask will increase the speed of your computation. So it can provide you scalability for your machine learning and data science workflows. And the best part is that Dask is easy. That means that if you know how to write your functions using anything standard like pandas, numpy, scikit-learn, then writing those functions and adding scalability utilizing Dask is not very tough. We will talk more about this later as well. Okay, so we will be using some of the codes going along, and the data which I will be using is of Kaggle. It is a Formula One data set, and it is laptimes.csv. So here we have race ID, we have driver ID, we have laps, we have positions, and we have the time taken for each lap. Let's talk about Dask networks now. So Dask networks constitute of three things: client, scheduler, and workers. So when you are writing some code, that is like a user-facing entry point, that is what is known as client. Now, when you are writing a code, you are giving some commands. These commands are transferred to the scheduler. So scheduler takes these commands and then it manages the workers. That means that it is assigning, it is distributing the task to these workers. And the workers are the one who are actually performing all the computations in parallel. Okay, so user interfaces which are used in Dask. So Dask has two kinds of user interfaces. One is high level and one is low level. So the high level one is which is like the scalable version of NumPy, Pandas, scikit-learn, etc. So the standard interface remains same. That when I say standard interface remains same, it means that the syntax which you are using already when using Pandas, NumPy, scikit-learn, you would be using the same kind of syntax here. But under the hood, Dask will be working via parallel computing. So all the computations will be much, much faster. Okay, so what are the low-level interface? Now suppose that you started writing your code in single node. For example, you were writing your code in Pandas, and then after some time you realize, okay, I should have used some scalability. This computation is taking a lot of time, and you don't want to convert it into Dask data frame at that time. In that case, you can just wrap it around Dask delayed or Dask features. And we will be talking and seeing the examples as well in detail later. Okay, so let's check some Dask collections. The first one is Dask data frame. So Dask data frame can be thought of as a bunch of Pandas data frame. So when you are using Pandas data frame, all the computations are done single-threaded way. But Dask data frame, it uses the partitions. So the computations are done in parallel on all the data frames. So let's check the example on the left-hand side. You can see both the codes. One is using Pandas, one is using Dask data frame. More or less, both of them look quite similar. But under the hood, how they are working is quite different. So check the second line where I'm reading the CSV file. So when I do that in Pandas, Pandas is going to read the file literally from starting to the end to end. But when I'm doing the same thing with Dask data frame, it is just going to read enough as per the information that it needs. That is, it is just going to read columns and also what are the data types. And that's it. Why? Because Dask is lazy. And actually, that's what makes it faster. It is not going to read all the lines. It is only going to read all these lines and do all the computations on that when it is explicitly asked to do so. So if you check the second line, the last line, I'm trying to find the mean lap time for each driver here. So the syntax looks same, group by, mean, just that when I'm using Dask data frame, I'm adding dot compute in the end. So adding that dot compute means that I am now explicitly telling Dask to do the computation. Okay, Dask arrays. So Dask arrays can be thought of as bunch of NumPy arrays. So the computation in Dask arrays is done in blocks. Let's check the example on the right-hand side. So here I have a NumPy array, which I have converted to Dask array, and it is in 2x2 chunks. So that means that I have got 4 blocks. So now when I have to do some computation, let's say like dot sum. So the computation will be done in all these 4 blocks in parallel. And once the computation is done in all 4 blocks in parallel, only then these 4 will be added. So if you compare it with the summation when I'm using just NumPy array, Dask array in this case is 4 times faster. minus the overhead. Okay, Dask bags. So Dask bags can be thought of as a bunch of lists. But why do we need Dask bags when we already have Dask data frames? So sometimes our data is not structured. It is unstructured or it is semi-structured. So performing some functions like mapping, like filtering, all these are very easy when you do those in Dask bags. Okay, so let's check the example here. I have a JSON file which has some information about some Formula One drivers, and I want to take out the name of the drivers whose rank is less than 10. So in this case, because it's a JSON file and I want to do some pre-processing, clean my data, I would be using Dask bags. And once the cleaning is done, then we can convert this into the flat columns and do the computations for machine learning later in Dask DataFrames. Okay, now coming back to the low-level interface, let's revise what we had learned earlier. We would be using low-level interface when we already have our code ready, which is, let's say, for example, in Pandas, and we do not want to convert it into Dask DataFrames, for example, or any other high-level interface. Or maybe sometimes the computations are complicated enough that doing those in Dask on its own might get maybe complex. So in these cases, you can just use your pre-existing code and wrap it around Dask delayed. But how does Dask delayed actually works? Let's take a look. So coming back to cars again, let's say that you have to build a car. There are two ways to build a car. The first one is that someone gives you instruction 1, let's say, put on a tire 1, you do that. You are given second instruction that put on a tire 2, you do that, and go back again. And this happens the entire day, to and fro. The other way to do is that someone gives you a list of instructions. You check that list, and then when you think the time is right, you call your 9 other friends, and then all of you work in parallel and try to build a car in the most optimized way. This is exactly how Dask delayed works. It does not compute every time a function is given to it. It just creates a task graph, and then it waits to be explicitly called, and then only it does all the computations in parallel. We will see an example here first. So I have 3 functions here, and this is in Pandas. So in first one, I'm trying to find the maximum time of the lap. The second one, finding the minimum time of the lap, and then I'm finding the range. So the C variable is giving me the output for range here. Now, I want to add scalability to this function. For that, I'm going to wrap it around Dask delayed. So when I'm calling here C variable again, you don't see the result. Instead, you see an object. Why is it so? Because Dask is lazy. It is not going to perform the computations until explicitly told to do so. So all this time, it is not doing any computation. Instead, it is preparing a graph, a task graph. So on my right-hand side, you can see the task graph that Dask delayed prepared. And it is trying to find ways it can optimize all the functions. So since finding maximum lap time and finding minimum lap time are not related to each other, it will be performing these computations in parallel. So, and once in the last line, if you see c.compute, that is when it is actually explicitly performing the computations. Okay, so it might happen that there are some computations which are real time, which you want results like immediately. In that case, you have an alternative to Dask delayed, which is Dask futures. So it extends the Python's concurrent futures interface, and it is not lazy. It performs the computations immediately. So in this example, I have the same functions which I was using before, but here I'm calling each function one by one utilizing .submit. So .submit will be transferring this task to the scheduler, which will be passing it to the workers, which will be performing it in parallel. And this result will be saved in a remote thread. And this result will be called as soon as you do c.result. So, and also it's a personal choice. Sometimes people prefer using Dask features over Dask delay. Okay, now let's get back to Formula One. Let's say Lewis Hamilton's ultimate aim is to drive a car fast. He has got two options. Either he can build a car himself and then drive fast, or he can let Mercedes build a car for him and then drive fast. Which one do you think he chose? I think he's telling us the answer. So now let's get back to options. First one is that they build the clusters themselves, manage the clusters themselves, Kubernetes and all the infrastructure issues, all that, or they have another option. They let Saturn Cloud do all the weightlifting and they just concentrate on doing some research work, building their models nicely, or on making decisions. So let's see that how we can create Dask clusters using Saturn Cloud. So this is the Saturn Cloud website. By the way, you can start using Saturn Cloud for free. We give you 64 GB of CPU. We give you free Dask, and we give you GPU along with that. So once you log into Saturn Cloud, you will see some resources here. So resources can be thought of as computation environment, and where each computation environment is connected to a hardware. So some of the resources here you see, these are all pre-built resources. That means that you can just click in and then start working. Everything is ready for you. Or if you want, you can build resources yourself as well, make some choices. So whenever anyone has to create Dask cluster in general, they have to have a resource associated with it. It can be a job, it can be a deployment, or it can be a Jupyter server. So let's use a Jupyter server here. So I choose the Jupyter server. I choose myself that how powerful I want my hardware to be. And then I click on New Dask cluster. So in just few clicks, I can determine that what should be the scheduler size, what should be the worker size, or how many workers I want, or how many cores I want in each process. And that's it. Now you start your Jupyter server, you start your Dask cluster, and you land into the very familiar page, which is Jupyter Labs. So here, you will be just importing the Saturn cluster class and then associating your Dask with Saturn cluster. And you don't need to use any other attributes or anything because your Dask clusters are already ready in just few clicks. So here on my right-hand side, you can see the information. It will show you the Dask dashboard. You can see how much memory you have, what are the workers you have. So Dask dashboards are they are quite interesting if you want to see how the workers are behaving and how much are you utilizing in all these workers. So this is how a Dask dashboard looks like. It will show you how are you using the workers in the most optimal way, or can you make some changes? So if you look at the Dask thread, and each rectangle that you see in task stream, that is a task. So each task has a color for itself. And the white part that you see in between, that means that at this time, the worker is idle. If you look at the progress, which is at the bottom, again, the color coding is same here. And it tells you that how is the progress for each task. And the gray part that you see there, it tells you that the task is ready to run. So this will really help you analyze that how are tasks being done by all the workers. On the left-hand side at the top, you can also see that how much memory is consumed by each worker. So if you see the 6.76 GB, that is the total memory being utilized by all the workers. This is like just one example. There are 4 other Dask dashboards that you can see. Okay, now let's check some examples to understand that how powerful Dask is. So the first one is hyperparameter tuning. On my left-hand side, I have 2 codes where I'm doing hyperparameter tuning via grid.search. So the first one is with single node and the second one is with Dask. If you look at both the codes, there is not much difference. For both of them, I am using grid.search. The syntax looks almost same, just that for single node, I'm using scikit-learn, and for Dask, I'm using Dask-ML, which is used in machine learning. So the syntax looks same, but the results are quite different. If you look at the result of single node, it seems that it is taking 3 hours to do hyperparameter tuning. And if you look at the results of Dask, for 3 workers, it is now the time has come down to almost 1/3, which is like 64 minutes. And if you are going to use 10 workers, it takes just 20 minutes. And then you increase your workers to 20 minutes, it takes just 11 minutes. So just with few changes, you can make your hyperparameter tuning run much faster. Okay, so Dask is fast, but can you make it faster? Yes, you can, if you integrate Dask with Rapids. But what are Rapids? So Rapids is a suite of open source libraries. It helps data scientists utilize GPUs in their machine learning pipelines. So let's take an example. Let's say you have pandas. So pandas, whenever it has to do computations, its all computations are done in CPU. So Rapids has set of libraries. So example, it has a CUDF library, which mirrors the API of pandas. So the syntax is almost same because of that, but instead of utilizing CPU for doing computations, CUDF will utilize GPU to do all the computations. That means you are scaling up. And then when you integrate Rapids with Dask, you're not only scaling up, you are doing scaling out because you can do all these computations in multiple machines. So when you are using, let's say, Dask DataFrame on its own is composed of bunch of pandas DataFrame. But when Dask and Rapid get integrated, then the Dask DataFrame will be composed of bunch of CUDF DataFrames. So the speed will be much, much faster. In fact, you can check this example, the link that I've provided here. It has some nice scenarios. Okay, so integrating Dask with PyTorch. PyTorch is quite popular for deep learning. And it is known fact that it does have parallel computing when you are on a single machine. But if you use Dask PyTorch DDP, then you can use multiple machines and distribute your training. So you can coordinate the parameter fitting if you are training for a model, or you can run multiple models on multiple workers and make training much, much faster. Check out this blog. It is quite interesting for speeding up neural network training with multiple GPUs and Dask. Okay, so wrapping up everything what we learned today, Dask increases the speed of your computations. Dask can scale out your machine learning workflows and data science workflows. The interface is quite familiar. So if you know how to use pandas, scikit-learn, switching to Dask is very easy. You can wrap it around, Dask steal it, and make that Dask is written in Python. So integrating it with the existing software projects like PyTorch and Rapids is easy, and it will make your code very efficient. So Thank you, everyone. That's all from my side.
Thank you
Thank
very
you.
much for speaking out. Like honestly, I'm not an expert myself in data science, but I actually understood some of the points you were making there. But, but yeah, you have a
I'm glad.
you have a wonderful day and enjoy the rest of the conference and weekend.